Hi everyone. This is the second video lecture on information theory. In this video we will see some solved example of previously discussed topic. The first problem tells you calculate the amount of information contained in a message if the probability of occurring of the message is 1 by 16. So for this, consider the formula for this problem, which is ik equals to log 2 1 by pk. This is the formula for calculate the amount of information contained in a message, where pk equals to 1 by 16, which is given here. By applying this formula, where ik equals to log 2 equals to 1 by 16, because pk equals to 1 by 16. Or it is log to 16. We can write 16 as a 2 to the power 4, and we know that in logarithmic, power can be replaced in the left hand side of the log. So it becomes 4 log 2 base 2, and 4 log 2 base 2 equals to 1. So answer is 4 bits. You should remember that the unit of information is bit. Now consider another problem. A card is selected at random from a pack of playing cards. If you have been told that it is red in color, how much information you have received. Also calculate how much more information you need to calculate, or you need to completely specify the card. So this problem has two parts. We will solve it one by one. The first part says from a pack of card you have to choose a red card and calculate how much information have you received by choosing it. Now we know that total number card is 52. There are equal number of red and black card present in a pack. You know that. So total number of red card equals to 52 by 2, which is 26. So probability of fetching a red card, which is denoted here PR, which is equal to 26 by 52, or half. So information of fetching a red card is IR log 2 1 by PR. So the value of PR equals to half. So it is log 2 base 2, which is equal to 1. Now comes to the second part. It says how much more information you needed to completely specify the card. Now, probability of getting a single unique card is 1 by 52, because the total number of card in a pack is 52, and the probability of getting a card is always, it is from 52 cards, it may be anyone. So that's why it is written as 1 by 52. Information of this card equals to log 2 1 by 1 by 52, or log 2 52. We use the formula log to calculate log 2 52. It is log 10 52 by log 10 2, which is 5.7 bits. But total number of information of fetching a red card equals to 1 bit. It is, we have already calculated this. This is 1 bit. So extra information needed is 5.7 minus 1, or 4.7 bits. It is our desired answer. Let's come with another problem. Consider discrete memory resource C that output 2 bits at a time. The source comprises two binary sources A and B, whose outputs are equally likely to occur, and each source contributing 1 bit. Suppose that the two sources within the source C are independent. What is the information content of each output from source C? So now you can see that it say a binary memoryless source C has two sources A and B. Each of source A and B produce two output 0 and 1. A also produce 0 and 1, B also produce 0 and 1. And the outputs are equally likely message. You know that what do you mean by equally likely? That means probability of getting the output is same for equally likely message. As the outputs are equally likely, so PA equals to PB, which is equal to half. Because here the probability of get these numbers are only two. One is 0 and other is 1. So that's why it is 1 by 2. Now the problem is to find out information content of each output from source C if A and B are independent binary source. Now in source C has two output source A and B. So each time output emitted from source C is 2. So the output will be 0, 0, 0, 1, 1, 0 and 1, 1. That means A will emit 0 and 1. That means C can emit either 0, 0 or 0, 1 or 1, 0. That means B equals to 1, A equals to 1, B equals to 0 or 1, 1. That means A equals to 1 and B equals to 1. So sample space of C, here you can see PA equals to half equals to P. And A and B are independent source. So output will be 0, 0, 0, 1, 1, 0 and 1, 1. So sample space of C equals to these four outputs only. And probability of having C equals to PC is equal to also PA equals to PB. PA into PB. It is not equal to, it is into. It is printed here. So PC equals to half into half. That is equal to 1 by 4. So information contained in C equals to IC equals to log of 2 1 by 1 by 4 or log 2 4, that is equal to 2 bits. So by this way you can easily calculate the problems related information theory. Try some other problem by your own, and if you have any doubt you can tell me. Now comes to another topic, which is average information in a message or entropy. Consider there are m different messages where m equals to m1, m2, m3 up to mn, and the total probability and probability of occurring each message is P1, P2 up to Pn. That means probability of getting a message M1 equals to P1, or probability of getting a M2 is P2. By this way, probability of getting a message Mn equals to Pn. So therefore, here the total probability is P, which is P equals to P1 plus P2 up to Pn. Now, suppose we have a sequence of L message. That means there are L number of message sequence and each sequence have M message. Now, probability of M1 equals to P1 for each message sequence. So, probability of M1 for L1 number of message sequence is P1 L. So in second sequence, probability of M1 message is 2P1. For your convenience, suppose here L number of message sequences present, and for each message sequence M1 to Mn message are same. All are same message sequences repeatedly sent up to Lth message sequence. Now for each message sequence, probability of getting M1 message is P1. So for Lth message sequence, the probability of getting a message uh, M1 is P1L. So we can write here P1L messages of M1 are transmitted. So P2L message of M2 are transmitted. That means for probability of getting a M2 message in each sequence is P2L up to L sequence. So information due to M1 is Im1 equals to log to 1 by P1. If P1L messages are transmitted, total information contained in M1 for L sequence of messages I1 total equals to P1L log to 1 by P1. Similarly, for I2 total for message M2 equals to P2L total log to 1 by P2. So I total equals to P1L log to 1 by P1 plus P2L log to 1 by P2. By this way, it comes up to Lth message sequence. So PNL log to 1 by PN. Average information equals to, we know that total information by number of message. So it is I total by L. Now I total is written here. So under bracket we can take common L, and under bracket we can write the remaining part. That means P1 log to 1 by P1 plus P2 log to 1 by P2 up to Pn log to 1 by Pn. This L and L can be cancelled, so it becomes only this part. It remains only this part. Or in summation form, it can be written as H equals to summation of k equals to 1 to n pk log to 1 by pk bits per symbol. This H is represented as average information or entropy. Symbolically, it is written as H. And the unit of entropy is bits per symbol. Now, there are certain properties of entropy. The first property say entropy is 0 if the event is sure. That is H equals to 0. It means if P equals to 1 or P equals to 0, because for surely event two cases will be occur. One is event must be occur, or second one is event will not occur. For this two cases surely can happen. So we have to check when Pk equals to 1 and when Pk equals to 0. So when Pk equals to 1, we can write the formula of entropy, and in place of Pk we can put 1. So it is log 2 1 by 1, or we can write log 10 1 by log 10 2. Now we know that log 10 1 equals to 0. So the total part will be 0. Now comes to when Pk equals to 0. Now formula for entropy is this, and we know anything it could be multiplied by 0 is always 0. That's why H equals to 0 when Pk equals to 0. Then we can say, so the first